today I'm going to run through three main areas. One is the very basics of OCF technology. The second is the organizational structure of OCF, and then I'll finish with a very short section on OCF's IPR policy as well, because I know that many of you are concerned about that. So first of all, the very basics of how OCF technology works. This is a very high-level overview. If you'd like more details, please come and ask me or check out the online documentation. But fundamentally, OCF is built around a REST architecture. So if you're familiar with web technologies, you will have heard of REST interfaces. And in the REST interactions, there is always a client and a server. In OCF, the server is the thing with the resource, and the client is the thing that is trying to access the resource, usually either an application or a cloud service. So the OCF framework goes onto both sides of this. The focus of OCF is really this resource model, which provides a standard description of the resources. Now, that isn't really just a standard description of this is a light bulb, this is a switch, this is a temperature sensor. This is a standard way of a standard grammar, a standard language for describing everything. So yes, there are standard descriptions for common devices, but more than that, there's a standard way of describing every device. And you can describe your own devices using the OCF language, and the applications will always interact with those resource descriptions in the same way. So if you're an application developer looking to talk to the Internet of Things, OCF means that you only have to learn one way to do it, which means that if everybody eventually, we hope, is going to be building devices that support OCF and writing applications that support OCF, then as long as the security and permission requirements are met, then every application can talk to every device, and every device can be a part of every application or service. It's a big vision.
OK， 那在 OCF 的技术方面呢，主要呢是用基于这个 resource 的概念来设计整套的系统，所以呢主要会分两个大的部分，一个部分在 client 这边 ，client 这边的话呢是去 access 这个 resource， 在 server 这边的话呢就是存放这个 resource。那么在这里所谈到的 resource 纯粹都是 software。那一个 resource 呢，可以 mapping 到你真正的 device 上面去，比如说你的这个空气清洁机、你的这个 LED 灯，这些真正的东西呢，叫做 entity。一个 entity 跟一个 resource 是一对一 mapping 所以你可以透过 OCF 所定义的这个标准一个方式，定义那个 resource 的方式呢，把你的这个整个的这个 entity 的东西全部都设计在这里头。那么 client 这一端就可以透过 OCF 的架构去存取 server 这一端的一个 resource 再去控制这个 entity， 就这样一个以 resource 为核心的一个设计理念。
That was a lot, wasn't it? I should let you speak more frequently. Okay, so smaller chunks from now on.
Okay.
Okay, so if an application is going to talk to a resource, it needs an API. So OCF includes, or actually this is really more IoTivity's area, but it includes a way to map this standard resource model onto a particular language. So we have an API mapping that is part of the framework, and that is what the application will use to talk to the resource model. So there can be API mappings for iOS, for Swift or Objective-C, for Android Java, for native Java, for C++, for Node.js. But again, if you're a developer, the basic concepts behind those language bindings are the same. It's the same resource model, whether you're on a device, on a sensor, or up in the cloud.
OK， 那存取 resource model 要透过这个 API 的部分，你可以透过 C++ 或者是 Node.js， 这边提供很多这个 language， 所以基本上很多 popular 应该都有了。
That seemed very short. You sure you got everything?
那这一段因为他讲的是 API， 我想大家应该都没有什么太大问题吧？可以吗？
Okay, some of you I know speak both languages. Make sure he stays honest. Okay, so in the same way, on the other side, on the server side, you also have a language mapping. In this case, it is used by a small piece of custom code that imports the resource into the framework. So you have some APIs that allow you to map any resource into the framework and have this little representation within. Oh, that doesn't really show up. Let's see. No. So the little yellow box is the representation of the resource within the framework.
OK， 右边这个橘色的部分就是一个 resource， 那 mapping 到这整个的这个 framework 里头哦。然后那个绿色就是一个 entity 的 handler， 对。
Of course, having these two representations of the server and the client on these two devices doesn't do any good unless they can talk to each other. So the final piece of the OCF framework is a mapping down onto different transports. So the first mapping that we have in OCF is down onto a local IP network, and that is via CoAP, DTLS, and UDP. But we also have, and I will come onto this in later slides, other mappings in development onto things like Bluetooth, into cloud-friendly transports as well. As long as a client and a server share a transport and all the security and permission aspects are kept, then the client can access the server's resources.
OK， 那在这个整个 resource model 以及 framework 底下呢，就是要把 mapping 到底层的 transportation 的 protocol 啊，所以这一段的话呢，一开始是做先 mapping 到 local IP， 那下一页会讲这个以后会做 mapping 到这个 Bluetooth 啊之类的。
So, if everybody, everywhere, develops OCF devices, OCF applications, and OCF services, this is all you need. Clearly, that is not the world that we live in, which is why, from the very start, OCF had the concept of how to talk to non-OCF devices, how you can use the same OCF APIs to talk to, for example, a Zigbee device. Obviously, to talk to a Zigbee device, you need a Zigbee radio on the main device, which has the OCF framework. But you also need some additional code. You need a translation layer. In OCF, we call that a protocol plugin. And if you have a look in IoTivity, you will find some code referring to a protocol plugin manager that allows you to add multiple plugins to talk to many different types of devices. So these could be standards like Zigbee or Bluetooth, or they could be custom devices from individual manufacturers that use proprietary protocols. One note of caution, if you go and look at IoTivity right now, you will find some code. That code is probably going to be changing. We're going to be talking about that in Taipei next week. But the concept is there, and we're going to be adding more capabilities very soon.
OK， 那在底层这边要真正透过 transportation layer 去做控制的时候，需要有一个机制。这个机制在 OCF 这边叫做 protocol plugin。 做一个这样一个转换，比如说 Zigbee 这一部分就会有一个 Zigbee 的 ，Bluetooth 有一个 Bluetooth， 啊，那透过这样的一个 plugin 的方式，可以 dynamic 啊去做一个 translation。因此呢，基本上大家要去 implement OCF 的时候，透过这整个的架构里头，你应该需要 take care 大概就是这个 protocol plugin 的部分。
Of course, once you have a resource imported into the OCF framework in this manner, you don't need to just access it from an application that's on the same device. You can use a model like we saw at the beginning so that you can access a non-OCF resource from another device. And this shows you how you can actually start to bridge across OCF devices, multiple hops to talk to a remote resource.
OK， 所以透过这样的一个方式，就可以 使用 OCF 整个架构去 access non-OCF 的 devices， 他们去 run ZigBee 啊、Z-Wave 啦这些啊。那整个的架构设计就是这张图。
I hope you can see how in this way, with this focus on the resource model and providing ways for the ecosystem collaborate, mapping this resource model down onto lots of different sorts of devices, both OCF devices and non-OCF devices, we're achieving the goal that Gary talked about earlier of making this easy for developers, of enabling the ecosystem to build applications and services that really deliver the value of the Internet of Things. Most of the developers who are going to be building those applications and services are not embedded programmers. They're people who today are building applications for your phone, they're building web apps. They need this sort of abstraction layer to make it easy for them to talk to the Internet of Things. And that is what I hope OCF, you can see, has achieved.
OK， 透过这样的一个 OCF 的架构去 access 所有的这些东西，然后最主要还是请大家看，就是说在 resource 这一部分整个抽象化之后，所以 follow 这个标准大家彼此互通 ，application 这边在 client 端，那个在 server 端，然后整个架构去存取它，对啊。
So as we talk about how OCF is organized, you're going to see that there are three main areas of technology that different groups focus on. Some are focusing on the core architecture of OCF, and that includes the security aspect. We have a separate work group that is just responsible for security because it's such an important part of the Internet of Things. If you've been following the news recently about some of the latest distributed denial of service attacks, you will absolutely understand why that is. We also have groups that focus on the resource model. There's a separate group that is just responsible for resource modeling. And they're also responsible for maintaining the one IOTA tool that Gary mentioned, which is our main repository for all of the resource models, the standardized resource models. And that operates almost like Wikipedia. Anybody can submit a resource model, but there are organizations like OCF and potentially others in the future that will be responsible for reviewing and approving those resource models. And then finally, there's other groups that are looking at transport mapping as well. So those are the three main areas that we look at in terms of technology, and as we go through the organizational structure, you'll be able to see that different groups are focusing on different aspects.
OCF 的这个主要的技术发展包括3大部分，一个核心的架构。那这个核心架构里面当然一定要包含 security， 因为 IoT 在领域里面 security 是非常重要的一环。好，那 resource model 这边的话呢，基本上有一个共通的一个 repository， 就是说要有一个集中式的 database。那么大家如果要开发自己的这个 resource 的时候呢，先去这个 database 去看一下啊，如果有你需要的你可以用，如果没有你需要的，你可以去 design 一个，透过一个流程的一个方式呢，可以就是说去follow 这个方式去制造一个这个 resource 出来。好，那当然还有一个部分就是要做 transport 的 mapping， 刚刚用那个架构已经有说过了，把 mapping 到底层的真正的 transportation 的这个 protocol 上。
Okay, let's now talk a little bit about OCF's organizational structure. Now, as Gary mentioned, we have two aspects to the organization. This is fairly unusual. You will see many examples elsewhere in the industry where you have an industry standard and also an open source project that implements that standard. What is unique about OCF is that we have both of these tied together from the very start. We also have a rule that nothing can be mandatory in the certification program unless you have both the specification and the open source. So you have to have both before you can have something that's mandatory in certification. Because remember, what we're trying to do is enable developers, and while specifications are useful, ultimately developers need code, and that's what an open source project does. It delivers that reference implementation of the OCF specification.
OK， 那 OCF 这边呢，定义的是规格之外，它还有 sponsor 这个 activity 的这种 open source project， 所以定义的规格，然后 activity 去实做一个 reference implementation。那你透过这个去参考到 reference implementation， 就会知道这个细部的一个架构是不是怎么去做，怎么去 implement 这 OCF 的一个这个 spec。
So within the actual open source side, within the Open Connectivity Foundation side, that is, if you're familiar with any of the other standards organizations, that's what that looks like. It looks like a standards organization. And then on the open source side, IoTivity is an open source project. It has independent governance. It's under the Linux Foundation, but is sponsored or funded really by OCF.
OK，OCF 定义这 spec， 然后呢，这个 IoTivity 是由一个公正的组织去 sponsor 的地方，所以这个 IoTivity 是一个 open source project， 然后是应该就是这样的意思啊。
So I'll go on now to talk a little bit more in depth about the structure of the Open Connectivity Foundation itself. You can see that I've laid out here several areas of work: specification, data modeling, open source coordination, which is making sure that that requirement is met of having both open source and spec ready at the same time. We have a certification group, and then we also have various other groups that are focused more on the business side of the organization, with marketing, membership, which Gary heads up, and strategy, which I head up.
OK，OCF 这边除了定义规格，然后有制定 data modeling 的方式，那更重要是要去协调 open source 这个 project 里面的 implementation 的这个过程啊，因为有很多技术细节必须要这个做一些协调。然后呢，当然很重要是要能够有一个认证的一个方式，一个机构。然后还有很多这个 business 上面的一些事务要处理，包括 marketing 的 strategy 的 membership 这些。
So we have a board of directors, and you saw Gary listing. We have, I think it's now 11 members, 10 or 11, 15. Okay, 15. Big board. Oh, that's with the latest appointment of yeah. We have 2 platinum members. So if you joined at the platinum level, every 2 years, all the platinum members can elect 2 nominees from their number to be on the board of directors. Besides that, they're all of the diamond level members. So that's the board. Below the board, we have 4 groups that all are operating on a roughly equal level. One of them is the Operation Management Steering Committee. That is chaired by the Executive Director. And underneath that, we have the main projects, and I'll come to those in detail in a moment. We then have a Business Steering Committee, a Technical Steering Committee, and the Certification Work Group. So you've got, between all of those, that's the main 4 categories of group that are within OCF: projects, business, technical, and certification. Within business, there's the Strategy Work Group, which I head. We have Liaison Task Group in there as well, which Dave Brenner, who's also going to be speaking in a moment, he heads that up. Business Development, Industrial Task Group, and Thread Task Group. The Thread Task Group is part of the liaison work that we have, so they're working with the Thread Group, and actually the OCF technology fits very well above the Thread organization, their technology. And the Industrial Task Group they've been working recently on a lot of quality of service additions to the OCF spec, but in the future they expect to be spinning out more projects which are focused on individual vertical markets within the industrial vertical. So smart cities, process control, we already have an automotive project, so that they're looking at this in narrower slices. The industrial market is just too big really to be covered in one effort. We then have the Marketing Work Group, headed by Kim, who is also here. We have PR, branding, digital marketing, the Events Task Group, which Dave Brenner is also running. He wears multiple hats. And of course, Richard, who heads the Asia Marketing Task Force, which is responsible for this great event today. And then we have the Membership Work Group that's responsible for all of our recruitment efforts, which Gary heads up. In the technical side, we have the Core Technology Work Group. So that's as the name suggests, the absolute core of that technology, the core architecture. We also have the bridging architecture there as well. The Security Work Group, responsible for all aspects of security across all of the other groups. So the access control lists, permissions, encryption, etc. Those are all included there. I should pause, shouldn't I? This is getting too much. Please.
OK， 在 Board 底下，现在应该成员有15位哈 ，Board。那底下有分几个大的这个群，那 Business Technical 跟 Certification。那 Business 底下的话有 Strategy Work Group、License TG、Business Development 这边还有工业的，还有 Strat。那他有特别提到，就是 Strat 这边是要跟他们有一些策略性合作。不过基本上因为 Strat 的这个层次是在比较 Network 层的，所以理论上应该不会跟 OCF 的标准有任何的冲突。不过因为他们会有跟 OCF 会有很密切的合作，去确保中间是不是会发生任何一个形式上的问题。然后 Marketing Work Group 这边有这些包括这个 Asia Marketing Task Force 是这个 Chairman 是 Richard Brown 还有底下的这个。那 Technical 这边最主要有核心的这个技术的 Work Group， 架构的部分以及跟别的标准去对接桥接的部分。那 Security 有一些 Security 安全性的这个 Work Group。Please.
So also in the technical steering committee, under that we have the data model review board. So that's the group that's responsible for all of the data models and for the 1IOTA test tool. And then we have the open source work group with various task groups underneath that as well. Certification work group is a little bit simpler, although no less important. They have the authorized test lab task group and also a test tool task group. And Ed Aegis, who will be speaking later, will describe to you the certification program, which is really key to actually shipping OCF products.
OK， 那在 Technical 这边的话呢，还有这个 Data Model Review 的 Board， 就是刚刚提到，就是我们最后你要去 define 自己的这个 Data Model 的时候，你提交 Data Model 会有这个 Review 这个 Board 来处理，里面还有一些这些 Tools 的这个 Test Group。那 Open Source 的这个工作群这边的话呢，有这个 Develop 开发者这个生态圈的，还有这个 Open Source 这种桥接的，还有这个规格去协调的这个 Workbook Task Group 工作群组。那 Certification 这边就相对简单，就是有一些去认证的单位测试的 lab， 还有这个测试的工具。那现在全球大概有6个，台湾那边也有1家，美国那边有2家，韩国也有。
So those are all areas of expertise. So if you want to know something about strategy, you go to the strategy work group. If you're doing something to do with the core technology, you need to talk to the core technology work group. Security is probably going to be interested in almost anything you do. Some of the simpler efforts that we have within OCF may only need some new data models, but they'll still need to talk to the data model review board. So to handle these sorts of projects which may have different needs and go across business, technical, certification, that is where the projects come in. And the projects sit under the Operation Management Steering Committee. There are 2 special projects which come from our mergers with 2 organizations. So that's the UP&P work group and the brand new AllSeen work group. So both of those groups are responsible for their own technology. So everything that they sort of came in with. So UP&P is continuing to maintain the existing media-based UP&P specs that they'd already spent years working on before they joined OCF. AllSeen will continue doing the same thing. There's a commitment to maintain the AllSeen specifications and certification program for at least 2 years, as gradually more of that work over time migrates into the rest of the OCF organization. And it may continue on longer than that if the member companies wish it to.
OK， 那这个每一个这些 work group 呢都有各自的职责，所以如果你有一些策略上的一些问题，你要去找的就是 strategy 的 work group。那你有 marketing 的这方面，你就要去找 marketing work group。那 open source、security 都是这样子。那这些都是 under 在 operation management， 就是整个的这种管理上面整个那在这底下呢有2个比较特别的这个 group， 一个是 UP&P， 一个是 AllSeen。那 UP&P 跟 AllSeen 被 merge 进来之后呢，他们都会持续的在他们原来的这个标准上面去 去持续的继续工作，就像 OCF 也一样，大概会维持1-2年的时间，继续把它的 spec 跟这些 certification 都会持续下去进行。可是这整个是协调的啊，在整个 OCF 架构上协调运作的。
So I will come back and talk in a little bit more detail about AllSeen, but there are many other projects within OCF. So we have some projects that are focused on particular markets like smart home, healthcare, automotive. And we expect to be adding others as well. I'm already mentioned that the industrial task group under strategy is going to be spinning out more projects that are focused on individual sub-verticals of the industrial market. We also have BLE GATT project, which as the name suggests is mapping the OCF resource model onto the Bluetooth Low Energy protocol. The CoAP Native Cloud is mapping onto really 3 technologies that are going to be useful for OCF in the cloud. One is CoAP over TCP, so you can use CoAP to communicate between different subnets. Another is the CoAP Resource Directory technology, which is a sort of a pub-sub technology that's useful for sharing information across wider networks. And then the third one is OAuth. So you take those 3 together and you have a pretty powerful cloud technology, which is still based on the OCF resource model. And then finally, we have another couple. The Wi-Fi easy setup is exactly what it suggests. It's about getting devices connected to a Wi-Fi network, but using the OCF framework to make that easier. And then the joint 1M to M engineering, joint 1M to M OCF engagement. I've forgotten exactly what it stands. JOEE. So, but that's 1M to M. That's OCF working with 1M to M to provide a very easy transition from one technology to another. There are some industries who are heavily invested in 1M to M, but it's mainly a cloud technology. They have very little technology or devices at the edge. They really want to be able to talk to the OCF ecosystem, and that's what that group is responsible for.
OK。除了这些 work group 之外呢，还有很多的 project 在进行，包括这个 smart home 智能居家的，解决这个智能居家这方面的这些相关的这些事情。然后 healthcare 就是 take care 那个 health 的这个部分的 project，automotive 智能这个自动车的部分哈，还有这个蓝牙 Bluetooth Low Power 就是蓝牙这个部分的这个 project 去做整合。然后 COAP 是在有限的这个 resource device 这边运行的这些 protocol 啊，又一个特别的一个 project。那在 WiFi 的这个 setup、easy setup 这边，就是也有这样的一个 project。所以在这整个的一个这些 project 下来之后呢，你可以看到就是说，除了这些 work group 外，它有解决一些特别的一些问题。那另外这个 1M、2M 这边的话的 JOEE 的 project， 这个专案主要是跟 1M、2M 的这个协议之间去做转换，因为这 1M、2M 跟这个 OCF 这边的协议是比较上层的，那这些 device talk 不同的语言，所以在这边要用一个这样的一个转换一个方式。Please.
Let me now go back and talk a little bit more about AllSeen. You may remember this slide that Gary showed, which said that we merged with AllSeen in October 2016. And we're going to be, next week, we have our first member meeting where both organizations are, members from both historic organizations are going to be in attendance. However, that is not the start of our work on providing compatibility between OCF and AllSeen devices. Whenever we renamed the organization OCF back in February of this year, that was because Microsoft, Qualcomm, and Electrolux, three of the largest companies from AllSeen, had joined what was OIC's board of directors. And that was a big enough change that it warranted changing the name of the organization. Because when they came over, we acquired the mandate to provide that compatibility, and we also, with the addition of Qualcomm and Microsoft, who are 2 of the biggest code contributors to AllSeen, we acquired the ability to do that and do a very good job of it. So the work to bring AllJoin and OCF together actually started in February of this year. It isn't just beginning now. We've been working on this for many months. And in fact, you could even argue that we started looking at this earlier because some of the people from Qualcomm who had been working on AllSeen from the very beginning actually joined Intel, and we put them on a project to see if this could work even before February. So there's been a lot of work going on that for, what's that now, 9 months, 10 months?
OK， 现在这个 OCF 跟 AllSeen 的这个 merge 的事情，虽然是发生在这个最近哈，但是之前因为 Microsoft 跟 Qualcomm 还有那个其他大的这个AllSeen 里面主要的成员都已经在2014年的时候就加入了，在前面之前就已经加入了这个OCF， 所以其实在 All Joint 的 integration 在2月的时候就已经有展开了啊，然后有这些重要的这个 AllSeen 的主要的成员在里头，所以呢，其实整个的工作推展都是一直持续在进行跟 AllSeen 之间的这个部分。
So the basic first step we have for bringing these ecosystems together is to make sure that OCF applications can talk to AllSeen devices and AllSeen applications can talk to OCF devices. So I already showed you what OCF's solution to that is, which is plugins. So we have been working on a plugin that will allow an AllSeen plugin for OCF. And AllJoin does have a similar technology. They call it a device service bridge. And there is going to be a device service bridge for the AllJoin framework that allows it to talk to OCF devices. So that is the first step. The second step really is to migrate as many of the future devices over to be OCF devices. So there will still be all these AllJoin devices in legacy, and we will maintain support for those for as long as we need to. But long term, the plan is to use OCF, is believe that that is the more futuristic looking, more forward looking technology. So what we have is...
Excuse me? Can you go back? OK， 短期之内 AllSeen 跟 OCF 的这个相容的话呢，是依据他们原来的就已经有的架构。原来在 AllJoin 那边这架构它就有一个 bridge， 可以跟其他的这个不同的协议去做这个转换。那 OCF 这边也有 plugin 去做转换，所以呢，短期之内会先依照他们原来的架构，不会改变太多，做一个转换。长期的话呢，还是要整个 migrate 到 OCF 的 spec 上头。
So what we will have is an AllSeen protocol plugin that will talk to mainly its local IP networks, and then those will talk to AllSeen devices. Now, we couldn't just take what was the OIC 1.1 specification and add an AllSeen plugin and have it work well. So a lot of the effort that we've had over the last year, again, since February, has been to add the capabilities that we need into the OCF framework so that we can have a clean mapping from an AllJoin device into OCF. And that is the version of the specification you saw listed on the roadmap, which is the OCF 1.0 spec. So OCF 1.0 adds capabilities into the OCF technology that allow a clean mapping from AllSeen into OCF.
OK， 那新的规格叫做 OCF 1.0， 在这里面呢会很清楚的定义怎么样从这个 AllSeen 的这个部分呢转换到 OCF 1.0 这个部分。那基本上就是整个会从 AllSeen 这个架构里头呢，会把它并到 OCF 1.0 的规格里头。
The good news is that all of those capabilities are things we would want it to add anyway. Things like full device introspection, which if you're a programmer, you will love. Other things like strong end-to-end encryption across multiple hops, across multiple different transports, which previously we didn't have. So these are not something that really has distracted OCF from its path. If anything, it has accelerated it. We have got a real addition of some great work that AllSeen has already done, which is why in some of the press releases about the joining together of OCF and AllSeen, you will hear the word best of both a lot. We really are trying to take the best of both of these technologies and put them together under one specification.
OK， 整个的合并最主要目的是希望能够截取 AllSeen 跟 OCF 两者之间最好的那个部分，就把它整合起来。所以在这部分会很仔细的去这个在两个的这个架构里面挑选出好的部分，作为一个 merge， 做一个整合的一个方式。
As we look forward into the next 12 months, the next 24 months, this is an area that the strategy work group is looking at, and we have a few areas that we are particularly interested in. One is working to make sure OCF has everything that's necessary for the industrial markets, those sub-verticals within the industrial ecosystem. We're looking at wearables, beaconing sensors, so even smaller sensors than we are currently supporting. We're looking at how to enable a robust plug-in ecosystem. So not just asking the OCF members or a few OCF members to build plugins, but making it easy for people who build devices to build a plugin for their device, even if their device isn't an OCF native device. And then looking even further ahead, we're also looking at things like distributed computing. The Open Fog Consortium, which focuses on distributed computing, thinks that OCF could be a very useful component in their overall platform that they're building. So there is a lot going on in OCF, and obviously some of this is going to be under NDA. This is not an NDA meeting, but I wanted to give you an idea of where this is going. We are looking at IoT, obviously, but there's a lot more coming down the pipe, and I think that you will find a lot of worthwhile use cases and technologies if you get involved with the organization.
未来的一些方向哈，在 Strategy Work Group 这边的未来方向呢，包括第一个在工业的这个市场 Industry Market 这一部分，那还有就是你穿戴式的比较小的，还有一些这种信标的这种这个感测器这些比较小的部分，那会OCF 会去支援这一部分的这些事物。然后还有就是说呢，对于现在现行很多的不同的协议、不同的这个生态系，还有不同的架构，都会尽量采用这种 plug-in 的方式兼容去做一些跟目前市场上各种不同的协议的这些沟通。那当然还有一块在 distributed computing 这一部分的话，因为 IoT 这一部分有很多时候呢，你可能需要的是及时的反应，你不太可能要等到 server 端再下来，所以那个 distributed computing 部分也会在这一部分做一些这个考量。最主要是这样子。
So now the bit I know you've all been waiting for, I'm going to be talking about intellectual property rights. I now know far too much about this subject. It's been a lot of conversations have taken place, a lot of disagreements even. And I think though that the OCF attitude towards IPR is the correct one. And I'm pleased to say that members of AllSeen eventually agreed with us. So there are actually two IPR policies. Just as we have the two sides of the organization, we have an IPR policy for each of them. They are both royalty free. So for the open source, we have Apache 2.0, which gives about the best patent coverage that you can get in any of the widely used open source licenses. I'll describe in a moment exactly how the details of that work. But on the Open Connectivity Foundation side, we have RAND-Z licensing between all of the members. So both of them are royalty-free, but they work in slightly different ways. And this may be important because you can use the IoTivity code without being an OCF member, and you will still get some patent coverage. What you don't get is the ability to brand your device as an OCF device, and you don't get the RAND-Z patent coverage, which is stronger than you get with Apache 2.0. So those are two big reasons to actually join OCF rather than just use the open source code. So the way that the Apache 2.0 license works, like any collaborative open source project, lots of different contributors contribute code. So in OCF's case, most of this is coming from corporations. A lot of those corporations have patents. And whenever any corporation contributes code, they are also contributing a patent license to any relevant patents they have on their piece of code, and only their piece of code. So whenever all of these bits of code get assembled into the overall project, each piece of code has its own patent license. And then the developer or the user gets all of those patent licenses whenever they actually use that code. Do I need to go back to the previous slide? Or do you want me to, how do you want to do this? Do you want me to talk?
这一部分谈到的是 patent 跟 license 啊，其实这一部分可能大家还是得要仔细去看一下他们 website 上面所真的这个 patent 的一个方式。那么基本上来讲，应该是你可以 deliver 你的 code 出去，那再加上你自己本身的这些 license， 然后整合进去之后，对啊，好，那 OK。
We're good. Okay, now that's not the only protection that you get with Apache 2.0, because if someone is using the code, they get the license. If that person or company sues another user for using their code, then the person who is suing loses their license.
I'm sorry.
Okay, so this is about the inbound license. So this is who is contributing patent licenses outwards, and you get, obviously you get a license. But if somebody sues, if somebody who is using the code, this is about the outbound license.
Okay.
If somebody is getting that license from the project, and they sue somebody else who's also using that code, the person who is suing, so company A sues company B, company A loses their license. Okay, so this is the protection around Apache 2.0 is based around who commits and who uses the code.
So basically, we don't have to worry about the suing.
Well,
so can I use the activity without any concern of the license?
well,
Or I have to be very careful?
so here's the thing, that because nobody has to sign a member agreement
Yes.
to participate in the open source
Yes.
project, the only protections you can put in place are connected with what code the company contributes and what code a company uses. So let's imagine there is first thing, nobody can protect you against a patent troll.
Okay.
So if somebody isn't committing code and somebody isn't using code, but they come along and say, I have a patent, sorry, we can't do anything about that.
Okay.
We also can't protect, in this scenario, from somebody who is committing code but not using code and claims that somebody else's code infringes on their patent.
So if I commit the code to the activity, I cannot claim like my patent.
Right. If I commit code, and you do not want me committing code, I'm not a good software programmer, but if I committed code, then Intel, because I'm an Intel employee, Intel could not sue somebody for using the code that I committed or that any other Intel employee committed.
Okay.
Also, if Intel was using IoTivity code in one of their products and Intel sued somebody else who was using IoTivity, Intel would lose the license for the code which they have in their product, which would probably mean that Intel would not want to do that. Probably.
Okay. So even
certainly for Intel. I can say certainly for Intel, but
I just have one question. Even if I have some patent and I still can commit the code to the activity and I can still own the patent, right? And
correct.
I can sue anyone to.
This only affects so first of all, you do not give up ownership of your patent under any circumstance, either with IoTivity or with the OCF licensing. And you also don't lose your ability to sue somebody who isn't using IoTivity, who isn't, it's only people who are involved with OCF or who are using IoTivity
I got it. I understand. So I don't have to worry about somebody steal my patent.
Correct.
Okay.
People won't steal your patent, and the other thing to know, it's all about mutual protection. And this is one of the reasons why when Gary says that we have 300 members, and this actually applies even more when we come to the OCF RANZ rules, the fact that we have 300 members and they're all working in IoT and they all have some really key patents, that should give you a warm feeling.
OK， 不好意思，因为基本上我对他们这个 license 这个方式也不是太过于了解。不过基本上来讲，可能就是不用太担心你自己本身拥有的专利，或是任何对于code的这些所有权，会因为这个方式而受到什么侵权的部分。大致上，那我是建议，可能他们，因为我看过他们那个网站上的这个有关于这方面的说明，我觉得可能大家如果针对 license 这部分疑问，还是得要自己再去把它那个仔细的看完他们的这个部分。对。
So that's Apache 2.0, and I said that the protection there is based on who commits code and who uses code. Not all OCF members will commit code. Not all OCF members may use code, but they're all members. And that is why the OCF certification and the RANZ licensing is useful, because that works differently. So imagine that we have the same 4 members. 3 of them are contributing towards the specification. And from that specification, we develop a certification program. A 5th company, 5th member, produces a product which they get certified. When they get that certification, they get a license to any relevant patents for the OCF compliant portion from all of the other members, including members. You see the 4th member bottom, they did not contribute to the code. They're just members, but they still get a license from that member. So when you produce your product, whether you use IoTivity or not, you could write your own implementation of the OCF spec, but if it is compliant, if it passes certification, you get a license for any relevant patent claims for the compliant portion of your product, so for the OCF bit. You don't get it for the entire product, but for the OCF bit, you get a license for all of those patents, and that's 300 companies and rising.
如果大家有兴趣了，因为我觉得这些部分，等我们真的要去 access 这些东西的时候，还是得要很小心 take care 任何有关于 license 的事。
That is the end of the very interesting section on patent licensing. That's the end of my section. We have a few minutes left. Do you want me to take questions now, or?
How to define the OCF device and the non-OCF device?
It's very simply, if it's an OCF device, it's running the OCF framework, so it's running some OCF code, and it will be discoverable by another device that's running the OCF framework, as long as the 2 share a transport.
If you can access the non-OCF device, how can you make sure the security and everything else?
That is a very good question. So whenever you're dealing with a non-OCF device, the security will be limited by the non-OCF protocol. There will also be the question of whenever you transition from the non-OCF protocol to the OCF protocol, there may be a security vulnerability there on that device, because you can't maintain the end-to-end security if you're bridging across protocols. And I think that this is actually one of the reasons why, as the IoT ecosystem develops, it will become more important that we have a shared language or shared framework which has one security model that provides complete end-to-end security. Because as soon as you switch, you're breaking that end-to-end security. Unless we do some very close collaboration with other platforms, and we may do. So 1M, 2M, maybe there's a possibility there that we won't need to break that if we work out something with them. But for a lot of the more legacy protocols, like Bluetooth or Zigbee or Z-Wave, which never envisioned having to extend security beyond their own walled garden, it won't be possible. So there is a security risk, maybe, or certainly you won't be able to implement all of the complex use cases with a non-OCF device, which is one of the reasons that we designed OCF, to support those more complex IoT use cases.
So basically, the security can be guaranteed in OCF, between OCF devices, but not out of the.
As much as security can ever be guaranteed, but yes, essentially, if you have that model which supports full end-to-end security, you can at least try, right? But if you don't have that, then you can't even try. You have to have a break. Now, it doesn't mean things are necessarily insecure. What it does mean is that the level of security will be dependent on the individual implementation. It won't be part of something that OCF can certify.
Okay.
OCF thread 的一个 TG 一个 task group 在里面，对。然后我理解的话就是说，在谷歌在 thread 上面是有 wave 的，然后 wave 和 OCF 我理解是有这个重叠的部分的，所以我想问一下您是怎么看待这个两者后面的一个关系？
Because we just saw the test group of the thread, and he wants to ask about the Google Wave and OCF. Because you never mentioned about the Wave.
No,
right?
I didn't mention that. So we've made no announcements about Google and Weave. Obviously, they are doing something that looks fairly similar. There may be some possibility of working with them in the future. I certainly, we would welcome that. But right now, the two are separate efforts. So I think that the architectures aren't hugely different, but at the moment it's quite clear that Google is wanting to tread their own path. And it's very hard right now to use Google Weave without also using Brillo, without also using Google's cloud services. So if you do choose to go down the Google Weave path, you really are going down a Google path, and that's not something that everybody wants to do.
这样子可以吗？
所以您的建议是采用 OCF 是吧？
So your suggestion is to use the OCF, not Google Wave.
Of course.
I have also one question about the Google Wave. Because you mentioned about the whole architecture and the technology between Wave and OCF is very different.
No, between Weave and OCF, I think there's the REST-based architecture and resource models. It's not a million miles apart.
Okay, so that's still possible to do the translation?
Okay, there's two questions there. One is technically possible, the other is legally permissible.
Yes.
Technically, almost certainly.
Okay.
Legally,
No idea.
we don't know yet.
Okay.
I would also add, from what we've been able to see, because Google is, I'm talking about publicly available information here. When Google initially started talking about Weave, there was a lot of focus on communication at the edge between devices. Over time, they seem to be focusing much more on a device talking to the cloud. So that's another difference between OCF and Google Weave.
还有谁有问题吗？
我来问一下，我有一个问题。My question is about the DOEE. You just mentioned that you have a project about the OCF and 1M, 2M, and I see the resource definition of OCF, and I find some service or some resource is defined by OCF, and at the same time it support multiple instances, and it supports the one M2M at the same time. My question is about in OCF and one M2M will use the unified resource in the future?
Don't know. Maybe. That's one of the things that group is looking into. So we would like to go in that direction. Obviously, the less duplication of effort we have in the industry, the better. The easier it is for the developers as well. And we have, with our OneIOTA tool, a way that we can potentially make that easier. So OneIOTA is, and you can go to oneiota.org and see the OCF data models, but that tool is designed to support multiple organizations. So we could have other organizations like 1M2M, and there's a few others that we're talking to, who would have their own resource models in that tool as well. Now that doesn't necessarily fix the problem, but if everything is in one place, it will encourage people to reuse what has already been done by other groups. So we maximize the reuse, minimize the duplication of effort. So we want to go in that direction in general, and the 1M2M group that we have is trying to work with 1M2M to see how far we can get along that path.
How would OCF devices be discovered? Is this a problem would be addressed by OCF specification?
Yes, is the short answer. Now, from the point of view of an application, it's the same for every transport. But that's for an application sitting above the framework. When the framework maps down onto each transport, the discovery mechanism will be different. So for a local area network, we're using COAP discovery, so UDP broadcast packets. When we discover over Bluetooth, that's mapping down onto the BLE advertising discovery frames. So this shows you how, from an application, those two things can look the same, but underneath they're very different. And that's one of the advantages of OCF, is that the developer doesn't need to understand the details of how to do discovery over local network, how to do discovery over Bluetooth, how to do discovery over Z-Wave. The framework takes care of that, abstracts it out to a higher level. But that mapping, how the resource model discovery maps down onto each individual transport, is part of the OCF spec. Does that answer your question?
Actually, my question is a little bit higher level, not only the device, but the device with the service. How would you discover the resource model or the service that the device would manufacturer would like the user to have to know how to use?
So you're saying from an application level, what does that look like?
Yes.
Okay, so there are a couple of well-known resources, OIC/res, OIC/D, which provide you the basic information of the device. Some of those will be pointers to what are common resources. So it could be a binary switch, it could be a temperature sensor, it could be some things that are well understood in the OCF world, but an individual manufacturer can also define their own resources. Now, it could be a simple binary switch, but it could be doing something that's custom for that manufacturer. Or it could be a completely different resource type. Now, with the advent of OCF 1.0, we have full device introspection so that the device can describe its full resource model, so that it can tell another device how to interact with it at what I would describe as a mechanical level. It doesn't provide any semantic understanding necessarily of custom resources, but if you're a programmer, you can get a piece of software and to discover a device and have it provide its full data model, and then write some code to interact with it much more easily. So those are the two things. There are some well-known resources that you interrogate. You ask questions first, and they will describe both common, well-known, well-understood resources, the sort of thing that will be standardized by OCF in OneIOTA. And then there will also be custom resources which are manufacturer-specific if a manufacturer chooses to do that. but they'll be described in the same place. Does that help?
Yes, thank you.